You don't know that kind of memory.
I have this table.
Well, we've also
and
been facing this
Catalina.
way the whole
That's
year,
true. Yeah,
so-
yeah, that's true.
I've looked back there maybe.
Why don't you look around a little bit?
Now it scares me now.
Expand
Yeah, I don't want to know.
your horizons.
It's just Brandon. Don't be scared. He said he can't turn around because he's scared.
Oh, so are you scared of Brandon?
Yeah, I'm scared of Brandon.
He says boo. All right. So we talked about the substitution rule here. And again, it's a very specific, unique case where you can find the derivative of a composition of a function, and it might help you along the way. Let's try this example. Take a look at this. Find the integral of the square root of 1 plus x squared times x to the fifth. What do you think my u is going to be? 1 plus x squared, right? Okay, so we're getting better at identifying what the u is. Okay, so what is du? What is du? 2x dx. Okay. Ruh-roh. Why do I say uh-oh? Because all I have is a 2x dx, right? What do I have still in the equation? X to the fifth dx. Okay, so maybe there's some way I can work around this. Now, do I see a 2? No, that 2 is going to have to go bye-bye. That's kind of, we've been doing that a lot in these cases, right? So get the whole number to go away. 1/2 du is x dx. Okay, so let's do that method of like working it backward a little bit, right? Okay, so this is the integral of the square root of u times x to the fifth dx. Now, I know x dx. Isn't another way to write x to the fifth x to the fourth times x? Right, x to the fourth times x to the first. Right, so I'll just write it out. X to the fourth times x to the first dx. Like that's just x to the fifth, right? Now, do you see the x dx? I see it right here. Okay, so this is the integral of the square root of u times x to the fourth times 1/2 du. Okay, can I perform the integral yet? No. I've got to get all x's gone. Bye-bye. Take a look at this step. I'm just going to rewrite this step. U is equal to 1 plus x squared, right? I need to write x to the fourth in terms of u, right? Watch when I subtract 1. So what is x to the fourth really equivalent to? What is x to the fourth really equivalent to? U minus 1 squared, right? Square both sides of this, and this gets me an equivalent statement of u minus 1 squared is equal to x squared squared, which is x to the fourth. Okay, so now, can I plug in something for x to the fourth? Yeah. So that's going to be the integral of, and I'm going to make that u to the 1/2 power times u minus 1 squared times 1/2 du. Now, you might be thinking, oh, great, I got to do another one of these substitution things because now I see something inside something else again. I see a u minus 1 inside that squared. No, we don't have to do that because we know algebra. And we can take u to the 1/2 times, well, what is u minus 1 squared? FOIL it out. That's u minus 1 times u minus 1, or u squared, outers and inners both negative 1u, minus 2u, plus negative 1 times negative 1 is positive 1. All right, just FOIL the u minus 1 squared. And now let's multiply in the u to the 1/2 and multiply into the just the constant 1/2. All right, let's distribute it in. Okay. This is going to get me u to the, well, what's 1/2 of 2? It's 1, right? Or sorry, no, I'm sorry. We're not multiplying those. We have to add exponents, right? Multiply with the bases. We add exponents. So that's like 2.5, right? 1/2 times, or sorry, 1/2 plus 2 is 2.5. So 5 over 2. You do the 5/2. Minus 2, and then this is u to the first plus 1/2. So u to the 1.5, so 3/2. Plus u to the 1/2 power. And you know what I'm going to do? I'm going to bring in this 1/2 as well. So I'm going to say 1/2. 1/2 of 2 is going to go away. Oh, come on, eraser. Going to go away. And then times 1/2 u squared. That's me distributing in this 1/2. I know I got to, but now can I evaluate the integral? Yeah, this is just a power rule, right? Just a polynomial rule. So that's equivalent to, we got 1/2 u to the, okay, 5/2 up 1. What's that going to turn out to be? 7/2, right? 5/2 plus 2/2 is 7/2 divided by 7/2. Minus, okay, we got u to the 3/2. Okay, so up 1, 5/2. U to the 5/2 over 5/2. Plus, and then we've got 1/2 u to the 3/2 over 3/2. Everybody follow me there? Okay, let's just reduce that in terms of the fraction. Oh, plus c. Can't forget about not plus c. Okay, so 1/2 divided by 7/2. Right? 1/2 divided by 7/2. Right? One seventh. Minus 2/5 u to the 5/2 plus, okay, we got 1/2 divided by 3/2, so times 2/3, 1/3. And in the end, don't leave u, put x back in. U was x squared plus 1. So this all said and done is 1/7 x squared plus 1 to the 7/2 minus 2/5 x squared plus 1 to the 5/2 plus 1/3 x squared plus 1 to the 3/2. Oops, that's a 3. Yikes. Sorry for the poor handwriting. I've seen much worse handwriting. Questions about that? That's a difficult one. That's a tricky one. The ability to see that you had to do a power on u, that's a little tricky. Right? That's about as difficult as it's going to get. Let's try one more of these. I got to do some trades, right? Yay, trigonometry. That's like back when I taught geometry, when we would do proofs, I would it was like positive association. You know, every time I said the word proofs, I'd say, yay. Like proofs, yay. Should I try to get associated with that word, associated with something positive? Like trigonometry, yay. Take your time, right? Think of something happy. That's like when my my daughter, one time when she was really sick, she was throwing up. We were like, think of something happy, think of something positive, like to try to get your mind out of throwing up, right? And so she was like at the toilet, she goes, I'm trying to think of bouncy houses. Like, oh, it's okay. All right. All right. Calculate the integral of tangent x dx. Now, the integral of tangent should seem like it's relatively simple. What really is tangent? How could we, instead of writing it as tangent, what is tangent again? Sine over cosine, right? So let's try that. So maybe I can use u substitution with this. Let's make u, we can either choose sine or cosine. Let's make u cosine. Let's make u cosine. Okay, so what is du? What is du? Negative sine x dx. Ooh. So this is really, I can get sine out of the numerator just by pushing it off to the right, right? So I can say the integral of 1 over, instead of cosine x, 1 over u, times, and we would have said sine x dx, right? But look what I have. Ooh, I've got that right there. I just need to get that negative to go to the other side, right? So this is really negative du of sine x dx. You follow me there? And now I see sine x dx there. So I can input that. That's going to be equivalent to, let's make that u to the negative first power. U to the negative first times negative du. That's not a minus, that's a negative, right? So like this, the integral of negative u to the negative first du. Okay, now let's perform the integral. Okay, so what is the integral of u to the negative first? ln, yeah. ln, and it's technically, because we're not a definite integral, because it's indefinite, there are no boundaries, we got to really say ln of absolute value of u. Don't forget the negative that was supposed to sit out front. Plus c. And then in the end, just plug back in cosine x. Negative natural log of the absolute value of cosine x plus c. Well, that's pretty cool. Tangent just had to be weird. Sine and cosine are just the other, themselves. Negatives, positives, whatever. Tangent, gotta be weird. Natural log. Crazy. All right, so this was all indefinite intervals, right? This was all indefinite interval, using the antiderivative to find the general form of the equation. So how do I deal with the substitution when it's a definite integral? Well, I'll just show you the rule, and we'll talk about it. How do you deal with it when it's a definite integral? Well, it's really only one minor change. If I give you boundaries, and I say they were from A to B, how does it change the boundaries? Well, you just got to run them through G. And what was G of x? G of x was just u. Right? Got to run them through u. So the only thing that's going to change with a definite integral is you're going to take those endpoints and run them through the function. Run them through u. Run them through g of x. And those are going to be your new endpoints. Now, the nice thing here is that if you do that step, you never have to turn it back into x. if you do that step, you don't actually have to turn it back into x. You can leave it in terms of u, and then run the definite integral, f of b minus f of a, using this b and a with u. It kind of like simplifies things. So the substitution process is going to remain the same. We're still going to do that exact same process of finding u, finding du, and then going from there. Uh-oh.
Are you recording?
Yes.
Just so you know, social studies is happening. You haven't checked your email.
No, I haven't. Oh, I bet we're being too loud up here. All right, let's take a look down. Okay, evaluate the integral from 4 to 0 to 4 on square root of 2x plus 1 dx using 6. Was this 6? Yeah, that's weird. Using the substitution rule. I don't know. Okay, so what am I going to use as u? 2x plus 1, right? Okay, so du is going to be 2 dx, right? Okay, do I have 2 dx? No, I just have dx. Let's get the 2 over to the other side. It's going to be 1/2 du is dx. This is all not new. This is all the same. Okay, so now this is going to turn into the integral of, notice that I'm not putting 0 and 4 on there yet, square root of u times 1/2 du. Now, what's going to be my lower boundary now? Well, I had it as 0, right? What's it going to turn into? Plug 0 into u. It's going to turn into 1, right? Because basically, and again, we're calling this g of x, right? That's our new, that's the composite piece of it, right? So just run that lower boundary through u. 2 times 0 plus 1 is 1. So what's my upper boundary going to turn into? Not 4, but 9. And now, once I've done that, I never have to turn it back into x. Right? I never have to turn it back into x. I can just use those boundaries and use my properties on u. Okay, so now this is going to be, let's turn that back into u to the 1/2 times 1/2 du. Okay, run that integral, u to the 3/2, and put the 1/2 out front over 3/2 from 1 to 9. Again, don't plug 2x plus 1 back in. You don't need to. You change the boundaries. Okay, so 1/2 divided by 3/2. 1/2 times 2/3 is 1/3. So that's going to be 1/3 u to the 3/2 from 1 to 9. So 1/3 9 to the 3/2 minus 1/3 1 to the 3/2. Okay, let's calculate that. Let's go 9 to the 1.5. I got to go to a third of that divided by 3. Ooh, that's just 9. Cool. Over there, that's 1. So 1 times 1/3 minus 1/3. So we got 0.867. Oh, I wrote 26 thirds. Fancy, Mr. Rabbit. 8.67. 8 and 2/3, if you will. 26 thirds. Notice that I never needed to plug 2x plus 1 back in. because I changed the boundaries. If I wanted to, I could work my way around it. I could plug 2x plus 1 back in and then run it through 0 and 4. That's fine too. Let's do another one. This always at 917, correct? I always have it in my head as 907. All right, I got the integral from 1 to 2 of dx over 3 minus 5x squared. Okay, what's u? 3 minus 5x. Okay, so du is negative 5 dx. Okay, so looking over here, this is going to be, you know what, let me take off the boundaries real quick. This is going to be, bring this dx out to the left, 1 over u squared dx on the right. Would you follow me there? Just push that dx off to the right side. Okay, so now this is negative 1/5, not plus 5, divided by negative 5. Negative 1/5 du is dx. So now, get rid of that and say negative 1/5 du. I struggle. Sometimes I like putting the parentheses there to remind myself that it's not minus 1/5 du, it's times negative 1/5. Now, what are my new boundaries going to be now that I've switched my variable? Well, what's 1 going to turn into? What's 1 going to turn into? Negative 2. 3 minus 5 times 1 is negative 2. What's 2 going to turn into? Negative 7. 3 minus 10, 2 times 5. 3 minus 10 is negative 7. Yeah, plug it into u. Plug it into u. Now, I bet some of you are like, that's weird. I got a bigger number minus a smaller. I got a bigger number on top, or smaller number on top than I do on the bottom. Is that okay? Yeah, that's fine. You can get around that. You can put a negative sign and then flip it. Remember that is a property that you could use. You could do negative, the integral of negative 2 to negative 7. That's fine. But it'll work itself out within the subtraction. So we don't really need to do that. So don't get tripped up on that. All right, so let's run the integral. I'm just going to make it look a little different. Negative 2 to negative 7 of negative 1/5 u to the negative second du. Just going to bring that power up out of the denominator and make it negative. Okie dokie. So we got negative 1/5 u to the negative first over negative 1 from negative 2, negative 7. Always do top minus bottom, remember. The over negative 1 is just going to cancel the negative on top. So this is going to end up 1/5 u to the negative first, negative 2, negative 7. So that is 1/5 negative 7 to the negative first minus 1/5 negative 2 to the negative first. Okay. Yeah. So we have 1/5 times 1/7, negative 1/7, right? Negative 1/7. So that decimal, negative 0.029 minus, and that's going to be minus a negative too, 1/5 times negative 2 to the negative first is negative 1/2. I get rid of that. 1/5. So 0.2 times 1/2. 0.1. And that's negative 0.1, so plus 0.1. So negative 0.029 minus 0.1 gets me 0.1, negative 0.129. Wait a second. What did I do wrong? I have 114. What did I do wrong? I should have been a net. I should have been a. Oh, I did a minus. What did I do a minus? Stupid Mr. Library. Stupid Mr. Library. Woo! 0.071. Oh, there we go. 0.071. There we go. That's not fair. Show me like 13 minutes. Yeah, we can do this real quick. Take a look at this one. You know, what do you think your U is going to be? Think it's going to be X? If we tried that, oh, sorry. If we just said U was X, we'd see du was dx, right? And when we try to do that, that would be ln of, do we see an ln of x in here? So that's not going to help us, is it? So u is not x. What do you think u is going to be then? ln of x. Okay, what is du then? What is the derivative of ln of x? 1 over x. Ooh, which will help us here. Take a look. Isn't this really just equivalent to 1 to e of 1 over x ln x dx? Right? Oh, and I should have reordered it. I should have put the ln in front, right? Because I see the 1 over x dx, don't I? Okay, so that is the integral of ln, oh no, just u. Just u. U du? Is that it? It's just u du. You do you. Now, I have to change the boundaries, right? You do you, man. You do. What does the 1 turn into? Ln of 1 is 0. What does e turn into? Ln of e. That's like saying log base e of e. 1. Oh, that's cool. From 0 to 1 of u du. Well, that would be u squared over 2 from 0 to 1. So 1/2 minus 0 over 2, so 0, so 1/2. That's pretty cool. That was a slick one. All right. There's one little thing that I do have to talk about. Should I save it for tomorrow?
Yeah.
Okay, we'll save it for tomorrow. We did a lot. Literally, it will be like 5 minutes worth of me talking tomorrow. And then the rest of the time should be work time. Let me ask you this, because I'm kind of open. We're going to have a quiz over section 5.5. Just this substitution stuff. That's it. Would you rather have it on Friday of this week or Monday of next week?
Monday. We have other stuff. I already have other stuff.
Who says Friday?
No.
Who says Monday?
You don't.
Damn.
I'll ask my other class too. It's like 50-50.
No. I need.
I'll take Friday. Take Friday.
Yeah.
I'll just take it Monday.
Yeah, but then that'd be super. Well, but if they want to take Friday, they can take Friday. I'll fix your credit.
Extra credit for taking it Friday.
Make it worth it. That's 3 less days of study.
I have to see. I can't remember if I did.
Friday, Saturday.
Let's see. Oh, let me actually stop the video first.